Hey everyone, I am Robert Groves, and my talk today is titled A Happy Path, Code Art with Processing. That might sound like a bunch of gibberish, I'll explain. But first, I want you all to think back to the first time you wrote code. Maybe it was a Hello World program, maybe you got something to move across the screen, maybe it was just getting something to compile successfully. But whatever it was, it probably felt a little bit like magic. You weren't worried about things like deadlines and bug reports or production servers. You were just kind of exploring, curious, and hopefully having fun. Fast forward to today, and most of our coding lives are a bit different. We build things because they're useful, or because they solve a problem, or sometimes even just because the ticket says so. And that's fine, it's all valuable, important work that we do. But along the way, that original sense of joy got buried under Jira tickets and Slack pings and production fires. So, in my experimenting with creative coding, I found it gave me a way to get back to that early feeling, where code wasn't just about solving problems. It was about making something surprising or playful or even a little weird. And that's what I mean by the happy path here. Not the unit test happy path where everything works perfectly. I mean your personal happy path back to the joy of coding. The one that reconnects us to why we fell in love with code in the first place. And that's what this talk is about, and I hope to show you one possible path to that. So my time is super short, and I am just a guy, so I'm gonna speed through this. I'm a developer, been doing this for a long time. I'm based in Chicago, worked in a few different industries over the years, many different languages, many different stacks. I consider myself a technology generalist. This is my first conference talk ever, so I'm excited to be here. Thank you. Thanks. So I recently started dabbling with creative coding earlier in this year, and that's what I'm here to share with you. So how many here have heard of processing? All right, a few. Okay, so the processing website describes it as a software sketchbook in language, and you'll hear these two terms when talking about processing, sketch and sketchbook. All that really refers to is sketch is a program written in processing, and a sketchbook is a directory of that contains those programs. To a more technical audience, I could say that it's a multi-platform open source programming language that has a bare bones IDE. It's built on Java. That's kind of how I snuck onto the Java track here. It's essentially a stripped down version of Java. And when you run your sketches from the IDE, it pre-processes it, puts all the additional syntax in there to make it a full-fledged Java program, and compiles and executes it. And it's used to create visuals with or without interactive elements, all with like a low barrier to entry. But that's not to say it's just for beginners, because while it has its roots in education, it's kind of evolved since then into a tool that professional creatives use to create finished pieces of art. So, how many here have heard the term creative coding or generative art? Okay, not many. So, there's no one specific definition of this. So, my interpretation and how I'll explain it today is it's code used to create something where the result is an experience and not just a set of functionalities to be used. Just as paint is a medium for painters or clay is a medium for sculptors, code itself can be used as a medium for creative expression. So the goal isn't to provide features or business value. Instead, it's to explore, to play, and to express ideas or feelings. So you may also hear these terms generative art, algorithmic art, or code art. All kind of encompasses the same idea. Code is an artistic medium. So the goals of this talk, if I could get all the way through it, is one, to convince you that anyone could do this. You don't have to, if you consider yourself unartistic or not creative, it doesn't matter. Everyone could do this. I want to show that processing is a decent tool to start your exploration. It kind of gets out of your way and just lets you start to explore the code. Let's see here. Oops. Oh. Oops, sorry about that. Okay. The third is I want to show you that how just by layering basics you could actually create something visually interesting. And then my last final challenge to you will be to actually play with this stuff and create a sketch of your own. Originally, I planned this originally this was a 2-hour workshop, cut down to a 25-minute talk. I was planning to do like a live coded speed run, and then I double checked and realized I'm not that crazy, so I have pre-built demos instead. But the downside to that is like when you're sketching, which is basically coding one of these processing programs, you'll run into things that you won't in a polished demo, right? And that's that sometimes you introduce a bug and it causes a glitch. And sometimes that glitch is like a surprising visual that you might even decide to keep in the sketch, or you might keep that bug as an idea for a different sketch. So because of time constraints, I have examples. So if you explore the slides later, you can see a sketch that I worked on with like these interacting particles and an early bug that it was caused when I was first developing it. Check that out. So on to the demos here. Let's see if this will work. All right, so I might skip and speed through some of these. This is a basic template for, so first of all, this is the processing IDE. Typical IDE, little hard on the eyes, but it does its job. This is essentially a blank template for where you would start with a dynamic sketch that has interactivity to it and that uses events that processing makes available. So there's two main methods, setup and draw. Setup is where you do your one-time initialization for your sketch. And then draw is essentially like a rendering loop. It's just gonna keep running infinitely. If you're just drawing a simple sketch where you don't need dynamic, you don't need anything dynamic, or you don't need to listen to like keyboard or mouse events, you could actually use no loop. And what that'll do is run setup once, one draw once, and then it's done. Size sets the size of the window. So if I run this right now, we'll get an 800 by 600 window. It's black background, and that's what the background function is doing here. When you pass a single value like that for the color, it's color between black and white, 0 through 255, and then shades of gray in between. So this next demo basically shows most of the 2D primitives that you could draw. But first I want to talk about the coordinate system. So in a processing sketch, your X axis goes along horizontally, your Y vertically, all starting in the top left corner. That's your 0, 0, all the way to the bottom right corner. That's whatever width and height you set in the size method. Typically, a lot of sketches sometimes reference the center of the sketch. I'll normally create these little easily referenceable variables that use these globally available width and height variables that are set based on the size that you set in setup. Colors in processing the color is a data type, and there's different ways you could specify the colors. Like I said, a single value is just from 0 to 255, black through white. There's a way to do it using hexadecimal. You could use regular HTML colors, or you could use RGB values. And you could also pass a fourth value to that, which sets the opacity, the alpha. The default color mode is RGB. That default mode lets you pass 0 through 255 for each of the different RGB colors. There's also an HSB mode. We'll maybe get to that in a bit. So I'm gonna run through all these primitives really quick. So point, just an XY value here. Drawing a point at the top left, the middle, and the bottom right, and that's just based on, here, the top left one was at 25x, 25y, and so on. Lines, you use the line method, and that essentially is taking two XY coordinates, your stop and your starting point. Here I have these in a loop, and it's just drawing a grid of 50 by 50 cells. You can see that. Rectangles. So the thing to know about the rectangle function is, so this is the first 2D one. The line and point are kind of one-dimensional. So with rectangles, you could actually set a fill in addition to setting like things like stroke and stroke weight. And there's two different modes for drawing a rectangle: corner and center. So when you say corner, it uses the XY value that you passed in to be the top left corner of like this purple one here that has like a little fill to it. And this blue rectangle is using center mode, which means that the XY you pass to it is going to draw the rectangle around that center. So ellipses and triangles and arcs are all similar. I'm going to let you explore the demo code through a link to a GitHub repo, just in the essence of time here, so I can get through a few more of these demos. Text has a few different ways to kind of align it. And there's also fonts you can use. You can use any TrueType font or OpenType font, but you have to convert it to format that processing uses, and that's done using this create font. And when you do this, like I downloaded this bit count font from Google Fonts, you have to put it inside of a data directory inside of your sketch directory. Like if I open this up, you'll see that this particular sketch has a data directory, and then the fonts are there, and any other resources that you need. And then you set the font using text font, and then there's different ways to align this, and I'll just run this so I can show the different ways. So the red dots here represent the XY coordinates that you wanted to draw the text to, but each one of them is using a different alignment mode. So that one there is left and top. So the left edge of the text that you're drawing is right on the XY coordinate, and then the same with the top of the text here, so like here and here. And then here is right and top, here is center, so it's in the center of the height of the font and center with the width of the font. And then this last one here is center bottom, which means it's centered vertically, and then the baseline of the text is at that XY coordinate. It's a little confusing when you first use it. That's kind of why I put the little red dot there. So let's see, that's text. I'm gonna jump to basic interactivity. So here's a sketch. You can see that the draw function is completely empty. So this sketch uses mouse and keyboard interaction. So there are these methods that processing makes available: mouse move, mouse drag, mouse press. And then for the keyboard, this should be, oops, don't know how that happened, released. Key released is when you actually release a key. And what I'm doing here is, like when I run this and I move the mouse, it's using this mouse X, mouse Y, which is a globally available variable that processing makes available. Another one is mouse button. And then the keys I'm using to kind of change the color of the fill for the shapes that are being drawn. And when I left click, or when I move the mouse, it'll draw a circle. If I click and drag the mouse, it's gonna draw a square. And if I right click, it'll clear the screen. So if we run this, you'll see that kind of that's a clear, this is changing. And then if I change the color, that's one, I'm sorry? Oh, yeah, right. So that's one way to add interactivity to your sketches. So let's see, controlled movement of shapes. So this sketch here, we got some of that we've already covered. I'm setting up a center XY, and this horizontal movement is basically gonna draw a circle, add an XY, using the shape size we set and set up. And then it has a rate that it's gonna move it along the horizontal axis, and then it has boundary checking, right? So this is an example of horizontal movement for a shape. We'll have, there's examples in here for vertical movement. And then there's also like a combined, doing the same kind of combination with the rate for both the x-axis and the y-axis. The better way to do this is typically to use the p-vector class. So the p-vector class kind of encapsulates that xy value and then gives you methods to do kind of vector math, which if you're not familiar with it, don't let it scare you. When you play with it, you'll get it. And so in this example, I'm using like 3 vectors, one for the position, one for the velocity, and one for the acceleration. So in my draw method, I'm just calling this vector movement function here. So that's going to continuously draw, right? So when it starts, it's just going to draw the circle at this position here. And if I do any of the key presses for up, down, left, or right, it's going to update this acceleration vector to, like for up, it's going to go negative along the y-axis by a small value. If I go down, it's going to be positive, and same for left and right, right? Left and right is going to go along the x-axis. And then there's boundary checking in here to allow it kind of to pass through the screen and go around the other side. So you can see here, when I run this, if I hold down the right key, it starts accelerating. If I hold it down more, the acceleration is just going to continue, and I could go left and slow it down and up and down. So this sketch here is an example of how you could do controlled movements. Let's see, where's my time? Okay. So there's a lot of other demos in here that show you things like randomness versus noise. And maybe I could do that one real quick because it's super quick. So when you're doing a sketch, randomness is sometimes just too all over the place. You want like a more natural, values that kind of aren't too far apart. Noise gets you that, and I have a simple demo here. So this basically draws, let's see here. This is random. So this one here, random versus noise. Essentially, it's drawing in red. It's drawing across the x-axis. It's drawing random red dots up and down the y-axis using a random value. And then for the green dots, it's using this Perlin noise function, which gives you a value between 0 and 1. And based on the value you pass into it, every time you call it, the larger that value is, the more the noise is going to be further apart and kind of simulate random. But the shorter these are from one call to the next, you're going to get smoother random numbers. And this is a visualization of that. So the red ones are random, whereas the green ones are using noise. And you can see that they flow more into more of a path. So I unfortunately am not going to get through all these demos, so I want to hit this one, because this is one that you could download these later and play with them. I hope you will. This is one that kind of puts it all together, and what I say, like using 3 R's of creative coding, which are rules, repetition, and randomness. So in this particular sketch, I have this class that I've called Elastic Shape, and all it's doing is it's kind of controlling the size of the shapes that are being rendered, so they'll shrink and grow at different rates. And this is all kind of standard stuff. I have an interface that provides the actual shape renderer to this class so that you could pass in different shapes. In this case, I'm using triangles, squares, and circles. And this is what this sketch does. And right now it's just drawing, so it's drawing the ellipse and the rectangle as static. And then the square, this triangle with these kind of trails on it. The trails are using Perlin noise to be kind of smoothly flowing. And this stuff grows and shrinks. And these are all just the simple shapes, simple 2D vectors that I showed before with a little bit of randomness to them. Now, if we increase this to say like 10 across, let's see here, yeah. And you'll see that, okay, now we get a grid of them, and it looks okay. They're all kind of doing the same thing. It's kind of visually interesting, but when you get to a certain point in a sketch, you could start kind of what I say vibing with it, and not in the terms of vibe coding, but you could vibe with some of the things that you're doing in the sketch, like maybe play around with the thickness, the weight. One easy kind of win that usually creates a visually interesting effect is not redrawing the background every time at the top of your draw loop. So like if I uncomment this, you'll see that now we kind of get these, it's not redrawing the background every time. So the previous shapes are leaving their trails, and it kind of creates this visually interesting pattern. And again, that's just something that is done using simple 2D primitives. One last one that I'll show, I guess, because this one's kind of neat. Oh, I don't think. So this one's using camera input. So in addition to like keyboard and mouse, you could pull in this methods from this processing video library, and here it's checking if you actually have cameras in your system. It will return those as a list, and then you can instantiate this capture method, which will capture the input from the camera. I'm capturing it at a super low resolution so that when I blow it up, it's super pixelated, because then below what I'm doing is kind of taking the average brightness from each pixel of the original source and then mapping that and kind of replacing the pixel with a character and setting the fill to be green, and then have a lower opacity based on the brightness of that pixel to begin with. And when I run this, it's initializing. Up in the left-hand corner here, once it's initialized, you'll see the actual video that it's processed. And then this is blown up, and you probably can't see it, but it's like CYC25. And based on the brightness of the individual pixels, that's what's coloring these individual characters that it's replaced with. So kind of a neat effect. All right, I got 2 minutes left. I hope that I hit all these goals. The last thing I want is to challenge you to download this and play with it. If you're not sure what to create, sometimes in that moment where you're like, I don't know what to create, I'm just, analysis paralysis, whatever, it's good to apply some constraints. So if you want to do this, take on the challenge, choose your favorite book, take 4 colors from the cover art, take a memorable line from the book, and add one or more repetitive elements, and just play with it and get something that you think looks funny or fun or interesting. If you're not a reader, you can use a song, and instead of a cover art, use the album art. If you're not a music lover and you're not a reader, maybe your 4 LLMs dressed in a trench coat. I don't know. If that's the case, then maybe somehow visualize your favorite algorithm, or maybe just a low-hanging fruit algorithm like a bubble sort or a string reverse, and share it out. So I didn't cover the sharing, but I will add a demo to do that, because there's basically methods that will allow you to take a screenshot, or there's methods that allow you to capture all the frames, and then you can use a library plugin that they have that pulls those frames together into an MP4. These resources will be in the slides, so you can go back to them. One special call out, check out Daniel Schiffman's site. He's excellent. And this site here has a section where they have artists that use processing in their work, and you can see like real light, like art installations. This QR code will take you to the demos. The demos are, the repo that has the demos in it also has the slides. You could find me at robertgroves.com. You could talk to me at that email address or out in the hallway. Thank you all.